Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the D programming language series. In this lesson, we're going to continue talking about structs, and this time static data as it's related to structs. So if you're coming from other programming languages, you've probably used static, and it effectively works the same way in the D programming language. So let's go ahead and look at an example in the D programming language here from dlang.org. So I'm actually going to go to the documentation, the language reference here, and let's go ahead down to structs here. Let's go ahead and find them here with structs and unions. Give that a click here. And we can go ahead and search for static here. And what I'm really looking for today, let me zoom in on that again, is about static fields or static member functions, just so we can again see how this data works here. Now, if I go ahead and search for static fields here, I'm not going to find too much information here, other than a struct can have static members or static member functions, the actual fields here. So let's actually look at the struct version here. But let me go ahead and remind you, if you haven't seen here, if I search for static in the language, that it's actually an attribute that we could put onto different objects here. So let's go ahead and try to find static here. Here it is here. And we can find that the static attribute applies to types, functions, and data. Static's ignored when applied to other declarations here. Okay, so we can see how it's sort of used here with a class, which we're going to learn about here. And let me go ahead and let me try to zoom in on this for you here. Static attribute here. Let me zoom. There we are. There. But basically what this means is we just have one instance per class, or when we learn about classes, it'll be the same as we're learning about structs here. And we can also have functions here, for instance, that are marked as static. So they belong to this instance here, and they just operate on the other static, or you can kind of think of it like global data as related to the class here. Okay, so a few other properties when talking about static member functions or static methods, they're never virtual. One instance per thread, not per object here. So that'll be one thing that you have to consider. And eventually, I think we'll talk about some multi-threaded stuff in this series as we move along here. Let's see, static nested functions can't access variables in the parent scope. And then, of course, static inside of a function persists after the function calls. And that's kind of the idea. This is just the regular function call, but you can think of it as the same thing even when it's part of a class here, that this value x persists, okay? Now it's scoped to this class where it's declared here, but that's the general idea. So let's look at an example that I've prepared here. This example is called student here, and I have some things like the name, the ID, and then two static fields here, the counter, and then I've also got a dynamic array here of references to the students. Okay, so just to show you an example of, hey, why might I actually use static, or again, to motivate this. So I'm going to use these regular fields here, and let me go ahead and annotate this. Regular fields, or member variables here, and my static fields here. Static fields which are shared across all instances of student. Okay, and that's the real takeaway here. The static data is actually allocated at compile time per instance for the struct here. So if I could draw a picture here of our program stack here, which I've done a few times in this series, if you've been following since the very start, where we have stuff like the text segment. We've got our stack memory here, which sort of grows like this. That's usually how we visualize it. We've got some heap data here, which in reality is a pointer to some sort of table, but we sort of visualize it here. And then we've got this data segment here, which could be things like global variables. And we might even split this up into the actual static data. And again, static we can think of as computed at compile time. In fact, there's some cool things we'll learn about in the D programming language regarding static if and static for each and so on. But again, this idea that somewhere here I will have allocated a student here. And let me go ahead and write it out here for you. For this particular struct student. And at the very least, I have some memory, some space here for these two static fields here, which I called the S counter. And I guess I just wrote this as student here. Sometimes I prefix my variables with S just as a convention, just so it's easier to kind of pick up on that it's static if you don't have a IDE or something, or just, again, as a convention. But anyways, the point is that this data here, or really these two things, lives in our executable when we compile it. It's there, it's shared for each of these instances of the student here, okay? So within a constructor, I can access static data, okay, because really I'm just accessing the student dot as counter and then the student references here. So we can see how I'm doing that in the constructor. But then per instance of my students, I have print here. And then if I have a static member function here, like I do, print all students, well, I can access any of these static fields here, okay? So let me go ahead and show you what this example does here. I'll go ahead and run it, and we'll walk through it. But basically, I allocate two students, Mike and Sue here. I give them, their constructors for 1 and 2, print out each of the students, and then I call this function here, which is a static member function here, right? It's right here at line 34. And notice that I'm just calling it on our struct name, which is student here. It's not on each of these instances or each of these objects, Mike and Sue. So that's how I use the static fields here. So if I go ahead and run this, you'll see I have Mike here. I have Sue. I'm printing out, let's see, each of the students here. Let me go ahead and show you what's going on in print here. And the counter, I guess I should say here. Let me go ahead and add just a little right here. Let's see, as counter. So I can call, or I should say I can access static member fields here. I think I could call the actual function here. Let's go ahead and just try it here. That's how we learn, right? On our student here, right? And I could do that here if I wanted, but that's just a note here. So we can always access the static information, but I can't access the individual instances, for example, in this way here. Okay, so again, with static, at compile time, and that's the way you can kind of think about this, we don't know about a particular instance of name or ID. I do know about the counter, right, because that's been allocated somewhere, and I do know about this data structure as well here, okay? So that's just a note as to why we can't access that static information here. But again, what is this program doing? Well, again, as far as this part here, where I have the regular fields with a name and ID, I think that's relatively self-explanatory with what we've been learning here, the name and the ID. But something that I use sometimes for this pattern with the static fields here is sometimes I want to just keep track of how many objects I've actually allocated, okay? And I should actually probably define a destructor here and have scounter minus minus and then remove the reference here. But this is kind of a neat little trick here where I could keep track or do some bookkeeping of every object that I've allocated. That might be, in this particular instance, this sort of serves as a log here. So if I store in this student references the actual object here, then at any time I could actually get a log here and just say, print off all the students that have been allocated at any time, and that might be, still alive and available here. And that's what's going on in this second part here. Okay, I'm just writing out the actual struct here. Now I could actually call student.print here, and let's actually just do it. Right, let's go ahead and do student.print, and it says error, none of the overloads of template right line here. Oops, that's because yeah, I just need to do student and spell it right, .print. Okay, and I could do that as well. Okay, so that could be another way to just have this nice sort of static member function that just prints out everything. But I'm going to leave it as it was here. So either way works. So whoops, let me leave it as is. There we are. So that's static fields and static member functions. Again, just remember that there's one instance allocated per struct or per class, and really that's all there is to it. All right. So with that said, folks, I'll go ahead and point you to my website if you want to go ahead and track your progress and all these lessons on structs, for instance, and keep track of where you left off. You're welcome to do that. And really quickly, I just want to thank everybody for watching. Thank all of the subscribers and members of this channel for your support. And with that said, folks, I'll look forward to your discussions below. And if you have any questions or concerns, please let me know there. Otherwise, I'll look forward to seeing you in the next video.